Remember, we're talking about how economists describe the productivity of a firm. Eventually, we're going to use this information when we prescribe what a firm should do to maximize its profits. But for now, we're concerned with the task of representing a firm's technology. Last time we looked at the total product curve, which tells us what a firm can do in the short run when it can vary only one of its inputs. We also described the marginal product of a firm. That is the additional output that the firm can produce by hiring an extra worker, an extra unit of the variable input. What I'd like to do now that we've discovered that marginal product is simply the slope of the total product curve, is I would like to draw a picture that puts the marginal product curve in a graph by itself. Let's look now at this diagram, and we've got another one of these now famous two-story diagrams. Remember, the trick with a two-story diagram is the graphs are related and they have the same variable measured on the horizontal axis. So in this case, we are measuring labor input on the horizontal axis in both pictures. On the upstairs picture, we're measuring total product on the vertical axis, and we're using those same numbers that we've been using all along to represent a total product, and those numbers are next door. In the graph below, we're going to now represent marginal product, and I've shown you those numbers. I calculated them before. It's the change in output that results from a change in the variable input, and these are my marginal product numbers. They're also next door as well. What I'm going to see is that when the curve is convex, that is, when the curve is increasing at an increasing rate, the marginal product will be increasing. That is, the slope is getting steeper, the marginal product is going to be increasing. When the slope is decreasing, that is, when the curve is concave, when total product is increasing at a decreasing rate, then the marginal product will be decreasing. This marginal product curve will be downward sloping. Finally, when the total product curve finally maxes out and heads south, that is, when extra workers actually decrease the total product of the operation, then the marginal product will itself be negative. So I've put the points from this diagram, from this chart, I put the points down here in the marginal product curve, and now I'm ready to connect them and draw the marginal product. So for one worker, the marginal product is 2. For the second worker, it's 10. For the third worker, it's 20, and so forth. So here is 2, here's 10. I made a mistake there. I don't know why I had that point for 10, because I'm using this for 10 and this for 20. So there's 20. You know, you got to be careful about this. And that means when I go back to a marginal product of, oh, I know why, because that isn't a marginal product of 10, it's a marginal product of 8. Well, I got ahead of myself, so I can mark that point off. Here's what the curve looks like. 2, 8, 20, 10, 5, 3, 1, and -1. And hey, I'll save my mistake here by making it part of the picture. I'll use that as the letter P for my marginal product curve. Hey, there's a little lesson. Sometimes you can turn your mistakes into part of the art, and that's what I've done here. Now, the marginal product curve shows me the slope of the total product curve at every point. And by connecting the dots, you can see where the curve is convex, the marginal product is increasing. Where the curve is concave, the marginal product is decreasing. And where the curve goes negative, the marginal product is below 0. So this curve represents the slope of this curve at every point. I want to throw in 2 little points of information here that you might find useful. Sometimes we write total product with an L in parentheses afterwards to indicate that total product, that is the total output that you can produce in the short run, given your technology and given your amount of fixed inputs, is a function of labor. So we write this as a function of labor. I could also write marginal product also as a function of labor. I could write MP of L, because the marginal product changes as I add additional workers to my factory. The next thing that I want to point out is that we're talking here about the number of workers who are working in the factory at a particular time. It's not like you're hiring one worker or then a second worker later in the week or a third worker even later. We're talking about 2 workers working together for a week or 3 workers working together for a week. See, the change in the marginal product is part of the technology. There are things that 2 workers can do to produce televisions that 1 worker can't do by herself. There are things that 3 workers could do that 2 workers can't do. Teamwork and specialization become possible as you add extra workers working together at the same time. So when we talk about the marginal product of technology, we're talking about how productivity changes as you add additional workers that are working at the same time, at once, together, over a given period of time, like a week. Finally, the last thing that I want to point out is I've been using the term convex and concave. I sometimes forget which is which, so I'll show you a little trick, a little memory trick. A memory trick, by the way, is called a mnemonic device. Some of my students were telling me the other day I'd used the expression mnemonic device, and they started telling me that they liked these demonic devices. They thought they were helpful. So here's a little demonic device to help you. Let's suppose you're standing here on the axis looking up at a curve, and if you're looking up and you see a cave, then we say that the curve is concave. But if you look up and you're looking for a cave and what you see doesn't look like a cave, if it's bowed downwards and you're looking for a cave, well then you would be frustrated or vexed. So this is convex. So here is where you're vexed, and here is where you actually see a cave. If the curve is concave, you look up and see a cave. If it isn't, then you're vexed. The curve is convex. So now we've got a picture of the marginal product curve, which is the slope of the total product curve. And what we'll add next is another measure of productivity that you may often hear about in the newspaper, that is output per worker. And that's called the average product of labor. So we'll